Hi, my name is Nejra Selimovic and I work as a technical content writer at the Things Industries. On this session, we will talk about something that has been a hot topic in TTN community for the past few months. That is, of course, the migration from V2 to the Things stack, or V3 as the Things Network community members like to call it. The first question that people usually ask is why to migrate from V2 to the Things stack, and why does it require user intervention? One of the reasons, of course, is that the V2 machines are planned to be shut down on December 31st, 2021. Before that happens, V2 is planned to become read-only on July 1st. It means that you won't be able to add any new devices, gateways, or applications. But the ones that you created before July 1st will keep working until December 31st. The second reason to migrate to the Things stack is because it will give you a lot of benefit. The Things stack is not just an update, it is a whole new LoRaWAN network stack that offers a lot of new features. Besides the modernized user interface, the Things stack is more secure and more scalable than V2. It also supports all LoRaWAN classes, all LoRaWAN versions including the latest ones, and all regional parameters. The Things stack offers interoperability with other LoRaWAN networks through a support for passive roaming, and it is planned to support the handover roaming in the future. The Things stack offers a lot of other features like support for firmware updates over the air, network load balancing techniques, and advanced integrations. With the Things stack, you can use the global joint server or some other joint server to issue and store your security keys, which will help you improve the security of your LoRaWAN solution. One of the most important advantages of the Things stack is its connection to Packet Broker, which will be also interesting for our session. I will also use this session to make a special announcement for the Things Network community members. With the latest The Things Stack release, you can also migrate your gateway to the Things Stack Community Edition while still providing uplink and downlink coverage for the Things Network V2. This means that you will be able to migrate your gateway to the Things Stack Community Edition to enhance its coverage, but you will still be able to provide data for your V2 applications. Of course, there are some requirements that you will need to fulfill. These requirements will be fully documented on our documentation page, but the point is that you can start migrating your devices and gateways as soon as possible because there is no more reason to wait. When it comes to migration, there are quite some ways to do it, and the implementation will depend on your specific use case. Before you start migrating your gateways and devices to the Things stack, you can make it easy for yourself by asking yourself a few questions. The first question would be how many devices are you planning to migrate, because it could make a difference when choosing the migration method. There are two available migration methods. The first one is using the Things stack console, while the second one is using the command line migration tool. Using the Things stack console implies registering end devices one by one on the Things stack. This will allow you to change some device parameters while registering them on the Things stack, but the negative side is that you won't be able to migrate groups of devices. On the other hand, the command line migration tool will allow you to migrate a single end device, a group of end devices, or even all devices in the application. The command line migration tool is convenient if you want to keep the most of your device's settings from V2. The next question is which type of device are you using? In general, OTAA devices are better and easier to migrate, especially when you can let them perform a new join on the Things stack network. When you let them do a new join, they will renegotiate some network parameters with the Things stack network server, and that will make it a lot easier for you. If you are using ABP, there is a high chance you will have to reprogram your device because some migration scenarios require that. We usually don't recommend using ABP, so if this is your case, this is a perfect opportunity to update the firmware of your device to change it to OTAA and to adopt some best practices. The next question would be, can your devices establish a new session? In case you can't access your device physically to trigger it for a new join, or you're afraid of breaking some applications, you're probably thinking of migrating your device together with its active session. For some scenarios, we enable this feature, so you can indeed migrate your device together with its active session, but we have to highlight that this is not a recommended practice and that we highly recommend migrating your devices without their active sessions. The last thing to consider is the possibility of migrating your gateways. If you are not able to migrate your gateway at the moment, Packet Broker might be the solution to your problem. And I say might because Packet Broker is capable of routing the traffic from V2 to the Things stack only in some scenarios. Please make sure to remember that even if you get things work using Packet Broker, you still have to find a way to migrate your gateway to the Things stack before the end of this year. If nothing is stopping you from migrating your gateway to the Things stack, we would like to kindly ask you to migrate it as soon as possible, since there is no more reasons to wait, and it will benefit both you and other members of the Things network community. Now, I will shortly explain Packet Broker role in the migration process and the conditions that it sets. If you want to know more details, I suggest you take a look at Packet Broker session held by our CTO, Johan Stocking, and take a look at our documentation page. Packet Broker is used to exchange traffic between LoRaWAN networks, and in that way to share coverage and to improve network performance and capacity. Packet Broker can be used to exchange traffic between V2 and the Things stack clusters. The important thing to remember is that the Things Network V2, the Things Stack Community Edition, and the Things Stack Cloud are the only deployments that are connected to Packet Broker by default. Besides those, the Things Stack Enterprise and the Things Stack Open Source can be configured to connect to Packet Broker by a user. We mentioned that Packet Broker is capable of properly routing the traffic from V2 to the Things stack deployments only in some scenarios. In order for this traffic to be properly routed via Packet Broker, both of your deployments, V2 and the Things stack, have to be connected to Packet Broker. We already mentioned that if you want to postpone the migration of your gateway, Packet Broker might be your friend because it is capable of routing the traffic from V2 deployments to the Things stack deployments in some scenarios. An important thing to remember is that migrating your device without its active session via Packet Broker probably won't be an issue, but migrating your device with its active session via Packet Broker is available only in one scenario, and that is in case of migration from the Things Industries V2 to the Things Stack Cloud deployment. In all other scenarios, you will have to either migrate your gateway to the Things Stack 2 or start a new device session. One of the reasons for this behavior is because Packet Broker has certain requirements regarding the device address parameter. What you need to know is that device addresses issued by the Things stack are always routable by Packet Broker. On the other hand, V2 device addresses are not routable by Packet Broker in general because V2 and the Things stack deployments maintain different device address blocks. V2 device addresses are not routable by Packet Broker except in one scenario, and that is, as I mentioned previously, in case of the migration from the Things Industries V2 to the Things Stack Cloud deployment. You probably already know that device address is a session parameter, so this gives you two options. The first option is to migrate your device to the Things stack together with its active session and keep the V2 device address. However, in this case, you will have to migrate your gateway to the Things stack too, except if you are migrating from the Things Industries V2 to the Things Stack Cloud. The second option is to assign devices with a new device address that was issued by the Things stack. For OTAA devices, it means performing a new join on the Things stack network, while for ABP devices, it means reprogramming the device. Another Packet Broker requirement is related to the RX1 delay parameter. The issue rises in the fact that the RX1 delay default value was 1 second on V2 and it is 5 seconds on the things stack. If you migrated your device to the things stack together with its active session, it is probably still using the default RX1 delay value from V2, and that is 1 second. If the traffic from V2 is supposed to be routed via packet broker to your the things stack deployment, that would probably be an issue. To resolve that, you have two options. The first option is to migrate your gateway to the things stack. The second option again depends on the type of device you are using. For OTAA devices, this means performing a new join on the things stack network. And for ABP devices, this means reprogramming the device with an RX1 delay value of 5 seconds. Next, we have two demos that we prepared to show you that the migration of devices and gateways from V2 to the things stack is probably easier than you think. These two demos are going to summarize two most common use cases amongst the Things Network community. For other use cases, please check our documentation page or contact our support. After demos, please stick around a few more minutes for a live Q&A with our CTO, Johan Stocking, and our backend developer, Agelos Kolaitis. This demo will summarize the steps to be taken to migrate your OTAA device from the Things Network V2 to the Things Stack Community Edition via Packet Broker by starting a new session. The first step that needs to be done is to create a new application on the Things Stack. Then you have to recreate payload formatters from V2 on the Things Stack. Next, you can migrate your end device to the Things Stack, but you also need to prevent it from rejoining the V2 network. When everything is prepared, you can trigger your OTAA device to perform a new join on the Things Stack network. I opened the Things Stack Community Edition in one window of my web browser, while in another window I opened the Things Network V2 console. On the Things Network V2, I own one registered gateway that is connected at the moment. Also, I own one application that is named Conference Demo, which contains one registered device. This device is named Test Device. If we click on this device and navigate to its Data tab, we will see that it is sending some traffic. The data that this device is sending is being decoded thanks to a decoder that is defined under payload formats. Now, we need to go back to the Things stack and do a first step towards migration. The first step is to add a new application. To do it, we only need to provide an application ID, which doesn't have to be the same as the one on V2. Next, we need to add an uplink payload formatter. We will choose JavaScript formatter type. We can literally reuse the whole decoder function from the Things Network V2 with one additional line that says bytes is equal input.bytes. Once you are done with adding the payload formatter function, click Save Changes. If we take a look at the End Devices section, we can see that there are no registered end devices. To add a new end device, we will click on this blue button on the right. If your device is available in the LoRaWAN device repository, you can add it to the Things stack using fewer steps, but in this demo, we will add the device manually. First, choose your activation mode. my device is OTAA device, so I choose OTAA. Then choose the LoRaWAN version. My device is using version 1.0.2 and it is the version that has been the most stable one for a long time, so it is probably your version too. Then click Start. Next, you need to add an end device ID. This ID doesn't have to match the device ID defined on the Things Network v2. Next, you need to provide an application EUI and the device EUI. These two values can be the same as the ones used on v2. So we will go back to the Things Network v2, copy the application EUI and paste it back to the Things stack. Then we will repeat this for device EUI. When you're done, click on the Network Layer Settings button. Next, you need to choose the frequency plan, which depends on your device, but also on the region where you're at. You also need to provide regional parameters version that your device is using. LoRaWAN class capabilities and advanced settings can remain untouched. Next, click the Join Settings button. In the last step of adding the end device, you need to provide an application key. You can auto-generate the application key on the Things stack, but in this demo, I will reuse the application key value from the Things Network v2. Go back to the Things Network v2, copy the application key to clipboard, and paste it in this field. Then finish by clicking the Add End Device button. Now we have added the end device to the Things stack, but we can see that the last seen info is unavailable, which means that our device still hasn't communicated with the Things stack. If we go back to the Things Network v2 and check the Data tab for our end device, we can see that the data is still reaching the Things Network v2. This means that the existing session between the Things Network v2 network server and our end device is not over yet. Now, the end device needs to perform a new join on the Things stack network in order to establish a new session. Before we trigger the device to perform a new join on the Things stack network, we need to prevent it from performing a rejoin to the v2 network. We can prevent the device from rejoining the v2 network if we change its application key on the Things Network v2. To do that, navigate to Device Settings, click the Auto Generate button next to the application key field, and click Save. Now, the device won't be able to rejoin the v2 network, but we still haven't triggered it to perform a new join on the Things stack network. What you need to do to trigger your device to perform a new join depends on your end device, and my end device is Arduino based, so I can just re-upload the existing code to trigger it. Next, go to the Live Data tab in the Things stack and enable the verbose stream checkbox. In a few seconds, you will see that your end device is now sending new join requests to the Things stack network server and that the Things stack network server is accepting it. Remember that we didn't migrate our gateway from the Things Network v2 to the Things stack. This means that device traffic, including join requests, is being routed from the Things Network v2 to the Things stack Community Edition via Packet Broker. If we take a look at the decoded payload, we can see that it is being properly decoded to the same values as on the Things Network v2. If we go back to the Things Network v2 console, we will see that no more messages have been received from the moment we triggered our device to perform a new join. The second demo will show you how to migrate an active OTAA device session and a gateway from the Things Network v2 to the Things Stack Community Edition. The first two steps to be taken are the same as in previous case. You have to create a new application on the Things stack and recreate payload formatters from v2 on the Things stack. The last step will be to migrate your end device together with its active session and your gateway to the Things stack too. The same as in previous demo, I opened the Things Stack Community Edition console in one window of my web browser, while in other window I opened the Things Network v2 console. On the Things Network v2, I own one gateway that is connected at the moment. I also own one application that has one registered device. The device is sending some data that is being decoded thanks to a decoder function defined under payload formats. Now it is the time to make a first step towards migration, and that is to add a new application on the Things stack. To create an application, you only need to provide an application ID. When you have added the application, the next step is to recreate the payload formatter from the Things Network v2. To do so, navigate to the left-hand menu, click on the payload formatters and select Uplink. Then select the JavaScript formatter type. You can again use the whole decoder function from the Things Network v2 with one additional line that says bytes is equal input.bytes. When you finish, click Save Changes. The next step will be to migrate the device from the Things Network v2 to this application on the Things stack. For that, in the previous demo we used the Add End Device feature, but in this demo we will use the Import End Devices feature. This feature allows you to import a JSON file containing device descriptions in the Things stack. This JSON file can be created by exporting end device descriptions from the Things Network v2 using the migration tool. The recommended version of the migration tool is 050 because this version supports session migration. Before we export the end device description from the Things Network v2, we need to define three environmental variables in our terminal, and those are the Things Network Application ID, application access key, and a frequency plan ID. Now, use this command in your terminal to export the end device description from the Things Network v2 to a JSON file. You only need to specify the Things Network v2 as a source and provide the end device ID. After exporting, check your folder for a newly created JSON file. If you open this JSON file, you will see that it contains all parameters that are associated with this device, like IDs, MAC settings, MAC state, root keys, channel plan, etc. The interesting thing to notice is that the RX1 delay has a value of 1 second, which was a default for the Things Network v2. It is important to remember that the Things Stack default value for RX1 delay is 5 seconds. If the migration was going via packet broker, this would represent a problem because the traffic from the end device probably wouldn't reach the Things Stack in time. In that case, you would have to change this value to 5 seconds using MEC commands. Since the session migration from the Things Network v2 to the Things Stack Community Edition, which we are demonstrating in this video, isn't available via packet broker and we are going to migrate our gateway to the Things Stack Community Edition too, the RX1 value of 1 second won't represent an issue. At the end of the JSON file, you can see the session-specific information like device address, session keys, and frame counters. If you take a look at the device settings on the Things Network v2, you will see that device address, network session key, and application session key have been wiped out. This means that this end device will no longer work on the Things Network v2. Just for the later reference, remember the time when the Things Network v2 received the last two messages from the end device. Now, we will import the JSON file in the Things stack and click the Create End Devices button. If the import was successful, click the Proceed button. We can see that this device has been successfully imported in the Things stack, together with its associated information like uplink and downlink counts, activation information, and session information. But the last seen info is unavailable, which means that this device still hasn't been communicating with the Things stack. The main reason is that the device address of this end device, which was exported from the Things Network v2, isn't routable by packet broker. To successfully complete the active session migration, we need to migrate the gateway from the Things Network v2 to the Things Stack Community Edition. To migrate the gateway, we first need to add the gateway on the Things Stack Community Edition. To do that, we first need to provide the gateway ID, which doesn't have to be the same as the one used on the Things Network v2. Then we need to provide the gateway EUI and the frequency plan. When finished, click the Create Gateway button. Now, the gateway has been added to the Things Stack Community Edition, but it is still not connected to it. The step to connect your gateway to the Things Stack Community Edition depends on the gateway that you're using. Since I'm using the UDP gateway, I only need to update the server address in the globalconf.json file to the Things Stack Community Edition gateway server address, which is eu1.cloud.thethings.network for my region. If I trigger my gateway for a reset, we will see that it connects to the Things Stack Community Edition almost immediately. If we go back to the application that we created previously, we can see that the end device is now connected to the Things Stack Community Edition too. If we go to the Live Data tab and check the messages that this end device is sending, we can see that they are being properly decoded to the same values as they were on the Things Network v2. If we go back to our end device settings on the Things Network v2, we will see that this end device is no longer connected there. We can see that no more messages are coming from our end device to the Things Network v2 since the moment we exported it together with its active session using the migration tool. Thank you for your attention. As mentioned before playing demos, we will now have a live Q&A with our CTO, Johan Stocking, and our backend developer, Agelos Kolaitis.